Okay, so I've got dy dx is equal to x squared plus y squared over xy. Sorry, this is question 3b, and what we're practicing here is we're going to practice ordinary differential equations and solving through substitution. Okay, so I want to end up with y is equal to, so I integrate both sides, but wait, I try and do that, and I have a problem because when I try to integrate the right hand side, I've got x's mixes with y's, so that's not going to happen. Then I'll try separation. I'll try to get the x's with the x's and the y's with the y's. Again, I'm going to run into a brick wall there. So I'm going to try substitution. So we always want our substitution to be v equals y over x. So let's just, everywhere we see, sorry, I'll rearrange that now. So that x is dividing, comes across to multiply, so y is equal to vx. So everywhere we see y now, let's replace it with vx. So dy dx is equal to, so x squared, and we're fine with the x's, that's grand, y squared, so that's going to be vx all to be squared. Then I've got xy, that's x times vx. Okay, just simplify that out a little bit. So dy dx is equal to x squared plus v squared x squared plus vx to be squared. Okay, and just like the last time, we can simplify that fraction. We can see there's an x squared in all of this. So I'll divide absolutely everything here by x squared. That's going to give me 1 plus v squared over v. Okay, similar enough to the last time. So now we've got a dy dx, which I don't want because I don't have y's anymore, so I just want a dv dx. So I'm going to use what I have here. So the integration or differentiation, dy dx is equal to, and just like in the last example, it's going to be v plus x dv dx. Okay, look back at the last video if you want to recap the derivative of that. So everywhere I have dy dx, I can replace it with this. So I've got b plus x times dv dx equals 1 plus v squared over v. Okay, so what I might do so is multiply everything by v. So v squared plus xv dv dx is equal to 1 plus v squared. Okay, I might bring my v squared over. So I've got xv dv dx. Now, if I bring v squared over, it's going to become minus v squared, so I'll be just left with the right-hand side with 1. Alright, so I'm just going to get rid of this dx, it's underneath here, so I've got xv dv equals dx is dividing, so when it comes across and multiplies, 1 dx. Alright, now I just need my x's with my x's and my v's with my dv's. So I've got v dv here, x is multiplying, so when it comes over it divides. And now I'm ready to integrate both sides. So the integral of, sorry, 1 second there. Okay, so the integral then of v being v squared over 2, and the integral of dx being the natural log of x. And then we'll do our plus, what's that, plus c. Natural log of x. I'll multiply everything by 2, so v squared equals 2 times the natural log of x, and I'm just going to say 2c as well, but it doesn't really matter because c is just an arbitrary constant anyway. Alright, we better bring back in for our v here. Oh, sorry, v is equal to, apologies, the square root of all of that, but remember that's a positive and a negative, plus 2c. Okay, so what is v again? We just remember that's a positive and negative there. So what was v? V is y over x, isn't it? It is. Yeah, so y over x is equal to plus or minus the square root of 2 times the natural log of x plus 2c. Now, if you wish, you can bring this 2 up here if it makes it easier to write. You can have the natural log of x squared. That's fine, but you don't have to. So y is equal to y over x is equal to the square root of 2 times the natural log of x plus 2c. But of course, y over x is also equal to the negative of the square root of 2 times the natural log of x plus c. And the last thing I'll do there is I'll bring my x over to multiply. So x times the square root of 2 times the natural log of x plus 2c. And the same on the other side, minus x times the square root of 2 times the natural log of x plus c.